Someone using factor rating might consider all of the factors to be important, but not necessarily to be of equal importance. That's why it's helpful to know as an analyst how to create weights to reflect different levels of importance. That's what you see going on here. Now let's look. Global Freightways has decided the two factors are not of equal importance in locating the maintenance facility. Rather, the issue of local operating cost is, here we go. Local operating cost is twice as important as the issue of centrality within Global Freightways network. Now, which location should it choose for the aircraft maintenance hangar? There are the two issues. Here are the 5 candidates and their scores. What we want to do is determine what weights to give each of the two issues to reflect this that we're told, their opinion that local operating costs are twice as important as centrality within the network. Now there's a variety of ways to do this, but typically when we are weighting scores, what we want is a weighting system that adds up to 1. Okay. How can we come up with, when we have two factors and one's twice as important, a proper weighting system in which the weight given to the issue that's twice as important is twice as large, but everything adds up to 1? Think of it as a series of steps. Create like a worksheet for yourself. Okay, centrality, that's the first issue. I'm not going to write the whole within the global network. And then costs. Okay, being the second issue, I'm not going to write local operating costs because this is just a scratch area here. Now what I am going to write here, I'm going to label my work preliminary weight. Now what do I mean by that? I'm going to look at this statement here. Local operating costs twice as important as centrality. I'm just going to write that. If centrality was a 1, this would be a 2, correct? That would fit this description. You say, oh, all right, are those the weights? No. That's what I meant by preliminary weight. Now create another column, finished weight, like what the weight is for real. How do you create the finished weight from that? First, add. Whatever you wrote here in order to reflect the statement, like this is 3 times as important as that and that's twice as important as that. There was no 3 times in this particular problem, but whatever problem you're working on, whatever numbers that you wrote down to reflect those statements, add them up. In this case, it adds up to 3. You say, all right, then what? The finished weight is your preliminary weight divided by the sum of all the weights. So for instance, the weight for centrality should be 1, that was the preliminary weight, divided by 3. The weight for cost should be 2, that was the preliminary weight, divided by 3. Now we have a weighting system that adds up to 1, and cost, local operating cost, look at that, 2/3 is twice as large as 1/3. It reflects the statement that it's twice as important. Oh, good. So is that the answer? No. The answer is we have to pick one of the airports. Now we have the weighting scheme we need to pick according to that preference, but we still have to calculate the scores for each one of the airports. Oh, all right, so more work. Let's see. First airport, NRT, for Tokyo's Narita Airport. Original scores, I'm looking up here, are a 7 for centrality and a 3.5 for local cost. So what we say is, well, it gets 1/3 credit for the centrality, plus it gets 2/3 credit, loosely speaking, for the low cost, 3.5. So its finished score, according to this preference scheme, 0.4667. Okay, well then, what about the second airport, Singapore's Changi Airport? It's 1/3 times its score, 9.5 for centrality, plus 2/3 times its score for local operating costs, that's 6, for a finished score of 7.167. Okay, well, what about, all right, and we just have to do it for each one of them. LAX in Los Angeles, 1/3 times 7, because that's its score for centrality, plus 2/3 times 4, that's its score for operating costs. I get 5. Then London's Gatwick Airport, 1/3 times 6, plus 2/3 times 8.5 is a combined weighted score of 7.667. And then finally, New York's Buffalo Niagara Airport, 1/3 times 4 plus 2/3 times 9 equals 7.33, basically 7 1/3. Oh, all right, so we calculated it's the scores now, the weighted scores, appropriately weighted scores for each one of the airports. Are we done? Almost. We're trying to pick one of the airports as the winner. We were told that higher numbers were more favorable, so we're just looking for here who came in with the absolute highest score. I scanned the list and it looks like the winner is London's Gatwick Airport because it's the largest value on this list. So to answer their question, Global Freightways should choose GAT London Gatwick Airport as the location for their new maintenance center, given that they consider the local operating costs to be twice as important as the issue of the centrality within their network.